Hello everyone, welcome to Exemplar Physics. In the previous videos, we have discussed the CBSE sample paper for the academic year 2020-2021, that is those students who are going to write the exam in this May. We have discussed how the questions are divided into several sections, how the marks are allotted, and also we have discussed the physics questions separately for each section, section A, section B, section C, and in today's video we will be discussing about section D. Section D consists of long answer type questions, each carrying 5 marks. So in section D, we have one question in physics, that is question number 36 with a choice. So let's see the question number 36. This question has a diagram. So let me draw the diagram first, then we'll read the question.
So the diagram consists of a circuit. So this chapter or this question has been taken from the chapter electricity. So we have a 60-volt battery here, and it has been connected to several bulbs through switches. So we are drawing bulb A, bulb B, bulb C, and bulb D. So we have switches here connected with switches.
Okay, so this is a symbol of switch. In textbook you have another symbol, that is key, right? When you insert the key, it is on. When you remove the dot, that is you take out the key, then it is off. In the same way, this is a switch. So this is the connecting material. So if you put it, if you connect it to the other end, so it is in on condition. If you open it like here, it is in off condition. There are some current ratings written there. So here we have 3 ampere, 4 ampere, 5 ampere and 3 ampere. So let me read the question for you. In the given circuit ABCD are 4 lamps connected with the battery 60 volts. Analyze the circuit to answer the following questions. So let's analyze the circuit. So by seeing the figure, what we know is we have a 60-volt battery. So let us write the polarity. This is positive, this is negative. And when the switches are in on condition, so these currents indicate the amount of current that passes through each bulb. So let's see the first question, question number 1. What is the combination of lamps arranged in? So we have to tell the combination. So this question is related to the combination of resistors. So if the current starts flowing from the battery, say I, now it's get divided into 4 parts. So current division is taking place. So obviously this is parallel combination. So the answer for the first one is parallel combination. I have already made several videos on the combination of resistances. If you wish, you can see them. The link for those videos will be in the description section. Question number 2. Explain with the reference of your above answer what are the advantages, any two, of the combination of lamps. So what is the advantage of parallel combination? We have to understand. Now I'll give you 3 advantages. In exam you can write any 2. First thing, let us understand what would happen. See here, if I turn on only one switch, so if I want only lamp A, so I can do this. If I want any 2, suppose I want A and C, I can do that, right? So the first and foremost advantage of parallel combination is the individual control of each lamp. So I'll write the first advantage as individual control. Second thing, if any of the lamps is faulty, then it does not affect the other lamps. So let me write that in words. If one or more lamps are faulty, it will not affect the working of other lamps. So if the question comes like this, what are the advantages of the parallel combination against the series combination, you can write the same points. If you see in a series circuit, suppose we have the same lamps, lamp A, lamp B, lamp C and lamp D connected in series with the same source. Then suppose if I want to turn off A, so if I turn off A, the current will not pass through the other lamps. So all other lamps will be off. So no individual control. Suppose any one or more, suppose say B lamp has been faulty. If B lamp has been faulty, so it will get open circuited and other lamps, since it is got open circuited, the other lamps will get affected. The other lamps I cannot use unless I replace B with another lamp. So in case that any lamp gets faulty, or the working of all other lamps will be affected. Moreover, see that in series the individual resistance keeps on adding. As the individual resistance keeps on adding, the net current passing through the circuit will decrease. And as a result, the third and most important point is that the lamps will not work at its full potential, whereas in parallel combination the lamps will work at full potential. See here, since they are connected in series, so the potential drop will be different, and the resistance getting added, again the potential drop is not 62 across each lamp, it has been decreased, and since the resistances are connected in series, so the net current will also decreasing, so all the bulbs do not work at full potential. Now look at here, when it is connected in parallel combination, the potential difference across each lamp is the same. When the potential difference is same, and then the current passing through each lamp will be according to its resistance, so it will work at full potential. So in this question they want to test whether you know the advantages of the parallel combination with the series. So you can write any two of the three I have given here. Now let's see the next question. For that I need to rub it. You can pause the video at any time to note down the points. So let's see question number 3. Explain with proper calculation which lamp glows brightest. So out of the 4, now let us do one thing. Let us close all switches. So when I close all the switches, all the lights, all the lamps will glow. So which out of the 4 is the brightest? Now he wants to test you whether you know the concept of power or not. So here the lamps are delivering the energy. So how do we define power here? Power is equal to energy delivered by per unit time. Energy delivered per unit time. So the one which is having the more power will deliver more energy, and hence it will glow more. What is the formula for power? So the formula for power is V into I. Here the voltage potential difference is same across each. So let us take for lamp A. So it is 60, and what is the current here? 3. So answer will be 180 watt. Now let's take bulb B. So power of bulb B is equal to potential difference same, since they are connected in parallel. 60 into 4, 6 4s are 24, 240 watts. PC, that is a power consumed or delivered by the bulb C. So how much is that? 60 into 5. So 60 5s are 6 5s are 30. So this is going to be 300 watt. And at the end, PD, the power delivered by bulb D, that is again 60 into 3. So 180. Now you see here, bulb A and bulb D, or lamp A and lamp D has the same values, and hence they will glow equally. The one which is having the maximum power delivery, that is the 300 watt, and now this is the answer. Remember, the question asks you to show the proper calculation. So this is the proper calculation. The power PC is equal to 60 volts into the current passing through the bulb, that is 5, so 300 watt. Or by just seeing the figure you can say, if the same question is been asked in MCQs, by seeing the figure you can say. Now you see here, power is equal to V into I, and since it is connected in parallel, so V is constant, so power becomes proportional to I. So the lamp through which more current is flowing will be the brightest. Now you can check 3, 4, 5, 3. So which is the maximum? 5. So this trick you will use when you are solving the MCQs. And since in the question he has asked for proper calculation, so this is how you are going to show. I hope that is clear. If you have any doubts, you can write it in the comment section. So the fourth and the final question is find out the total resistance of the circuit. So we need to find out the total resistance of the circuit. So I will be using the Ohm's law. I will be using Ohm's law, the fourth part. So what is Ohm's law? The potential difference across the, so let us assume that there is only one conductor. So this parallel combination will lead to some equivalent resistance, right? These parallel combination will lead to some equivalent resistance. So let that equivalent resistance be R equivalent, REQ. Okay? And because of that, some current is flowing, right? Coming out of the battery, that is I. So I is equal to, so V is equal to I into R equivalent. So this is we are going to use. Now see that. So we want R equivalent. So from the figure we can say, or from the equation we can say V by I. So V is the battery voltage, total battery voltage. And I is the total current. How much is the total current? 3 plus 4 plus 5 plus 3. How much is this? 3 plus 4, 7, 7 plus 5, 12, 12 plus 3, 15. So 15 ones are 15, 4s are. So 4 ohms is the equivalent resistance of this circuit. See, I have to show it with proper calculation. Remember, this is 5 marks question. So that is how you are going to solve. If you have any doubts related to the parallel and series combination or regarding the Ohm's law, the videos are, I have made a separate playlist for the chapter electricity. You can go through it, and if you have seen this sample paper, okay, so electricity chapter is really important. Now there is a choice question for this. So let us do the choice question. Remember, when you are given choice, you should analyze which concept you know better, and you should go for answering that. So let's see the choice question. So 36 or. So there is a diagram there. So let me draw the diagram for you. So this is a current carrying conductor and its name is PQ, and current is flowing in this direction. Okay, so let me use black color for the direction. So this is the direction of the current, and there are 2 points S and R. So let me draw R here, and here is the S. Okay, and R is at a distance of R1. So this distance is R1 and S is at a distance of R2 from the current carrying conductor. So this is the diagram we have. Now let's see the question. PQ is current carrying conductor in a plane of paper as shown in the figure below. So this is on a plane of paper. So we have a board is our plane on which the conductor is placed. Now let's see. Find the direction of magnetic fields produced by it at points R and S. So they want the direction. So this question has already been asked in section A, that is to draw the magnetic field lines for current carrying conductor. So we will be using the same thing here. So what is the shape of magnetic field lines for a straight current carrying conductor? Those are concentric circles. So let me draw concentric circles for you. So I'll be drawing the dotted lines for the magnetic field lines which are behind the conductor on the other side, and the dark one indicates the magnetic field lines on this plane on above the current carrying conductor. The shape of the magnetic field lines are concentric circles. So I'm showing dotted lines. Those lines are behind the conductor, behind the conductor, and the one which are solid, those are above the conductor. So what is the shape of magnetic field lines for straight current carrying conductor? Concentric circles. And how to get the direction of magnetic field lines? By using right hand thumb rule. So this is my right hand, and I'll place my right thumb in the direction of current, then the circled fingers, then the encircled fingers, curved fingers gives the direction of magnetic field lines. Now you see that if I take here on the above the conductor, the circle fingers are moving from left to right, right? And when I am seeing at the point, right, where is the R is on the surface. So if I see at position R, the curved fingers are moving into the plane. So since they are moving into the plane, how do I represent into the plane? I'll draw cross inside a circle. Now see that at behind the conductor, how the circled fingers are moving. They are moving from right to left. So this is the direction from right to left. And when I see here at S, so at this point the direction of the force, circle fingers are out of the plane. So how do I show out of the plane? By drawing a dot in a circle. So now the question is what is this is the first question. Let us write first question of this choice question of 36. Find the direction of magnetic field produced by it at points. So at R, what is the direction? At R we have the direction into the plane. The magnetic field lines are moving into the plane, and at S we have out of the plane. So this is the question. Next, second one. Given R1 is greater than R2, you can see from the figure also, R1 is greater than R2. Where will the strength of magnetic field be larger? Give reasons. So we have to tell where it is larger, either it is at S or R, and we have to also need to tell the reason. So you already know, if I have a magnet here, so the closer I am to the magnet, the more force. Suppose I am a magnetic material. If the closer I am toward near the magnet, so more force I will experience. Suppose I am at this point. Let us call this point as A, and let us call this point as B. So the magnetic material kept at A will experience more force since it is closer to the magnet than B. Similarly, we'll apply the same rule here. So since this is for the second part, since R1 is greater than R2, so at S, okay, at S, the magnetic field will be more. So let us represent magnetic field at S as BS, and let us represent the magnetic field at R as BR. So you can clearly say magnetic field at S is greater than that at R. And what is the explanation? You can give a simple explanation that the magnetic field is inversely proportional to the distance, okay, inversely proportional to the distance of the point at which its effect is to be felt. So that is the explanation, and that's enough. Now let's see the next question. If the polarity of the battery connected to the wire is reversed, if I am reversing the polarity of the battery, what will happen? The current direction will be reversed. How would the direction of magnetic field be changed? So if I am reversing the polarity of the battery, then the current direction will be reversed. Now it was going up, now it will move down. Now again I'll use right hand thumb rule. So let me rub it better if I rub these lines so that it will be clear. Okay, so this is our current carrying conductor, and I have changed the polarity. So if I change the polarity of the battery, the direction of the current will be opposite direction. Now it flows from P to Q. Earlier it was flowing from Q to P. So again the shape, there is no change in the shape of magnetic field lines. So what is the shape? Concentric circles. Okay, how many you want, you can draw that many concentric circles, but it should look neat. Please give emphasis in the clean paper presentation. Now how to get the direction? By using right hand thumb rule. Thumb should be in the direction of current. Thumb should be in the direction of current. Current is downward, so thumb is downward. So circled fingers will give the direction of magnetic field lines. And if I see on the space above the conductor, the circled fingers are moving from right to left. Now at this point on the left side, they are entering the plane, and at the behind the conductor they are moving from left to right, and here they are coming out. So you can use your right hand to find this. Okay, so earlier, now compare with the earlier diagram. Now you see magnetic field lines, our direction has reversed. So what is the answer for the third one? If the polarity of the batteries are reversed, then the current also gets reversed. So the magnetic field will also get reversed. So the answer is magnetic field will also get reversed. So this is the answer. So I hope you have understood. And let's see the final question. Question number 4. Explain the rule that is used to find the direction of magnetic field for straight current carrying conductor. So what is the rule we have been using from the since question number 1 of this? The rule is right hand thumb rule. Okay, right hand thumb rule. So what is the question? He says to explain. So how to explain? Take your right hand, okay, if, okay, in such a way, this position, okay, this position of like, okay, like the video, position of like, or you can say a thumbs up, the position of thumbs up. So how to place it? Okay, stretch your thumb and the fingers will be circled, and the fingers will be circled. So this is how you have to place your hand. If thumb represents the direction of current, if, please write it in words. if thumb represents the direction of current passing through straight current carrying conductor, then circled fingers will give the direction of magnetic field lines. So circled fingers or encircled fingers, any word you can use, circled fingers will give direction of magnetic field lines. I hope you are understanding. So you have to write these things in a sentence. So this is the end of the sample paper. So I hope you have learned something from this video and the previous videos. If you have any doubts, please write it in the comment section. Okay, like the video, share with your friends and family members, and keep watching the channel. Thank you.